Our next unit, we're studying trigonometry, which you've seen before, sine, cosine, and tangent, and I'm sure you're all familiar with SOHCAHTOA. So trig studies the relationship between sides and angles in triangles. We're also going to see three new trig functions. Cosecant is the reciprocal of sine. Remember, sine is opposite over hypotenuse. Cosecant flips that and becomes hypotenuse over opposite. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. First thing we're going to do is a quick review of SOHCAHTOA, and I'll show you how to generate those three new trig functions as well. Starting off with sine of theta, make sure you identify where that angle is first. Sine is opposite over hypotenuse. But we're missing our hypotenuse, so we need to solve for it. Remember Pythagorean theorem in a right triangle, so we have a squared plus b squared equals c squared. 9 plus 16 is 25, and the square root of 25 is 5. So that's our missing side. And now we can finish setting up the sign. Opposite over hypotenuse. Cosine is adjacent, or the side next to the angle, over hypotenuse. So we have 3/5 for our cosine. Tangent is opposite over adjacent. Setting up those reciprocal functions, cosecant is the reciprocal of sine. The way that I remember that is that it doesn't make sense. You would think cosecant is the reciprocal of cosine, but they are not. Cosecant goes with sine, secant goes with cosine. So if you remember that it doesn't make sense, it's not normal, then you should have an easier time remembering which one to flip for each of these three new ones. Since cosecant is the reciprocal of sine, we take 4/5 and flip it. Secant is the reciprocal of cosine, so we'll take that 3/5 and flip it. And cotangent is the reciprocal of tangent, so we'll take that 4/3 and flip it. Next, we're given one trig function. We'll set up the right triangle and solve for the other 5 functions. Knowing cotangent is 5, and I'm much more familiar with SOHCAHTOA, as are you, I'm going to find the reciprocal of that and say that tangent is the reciprocal of 5, or 1/5. That'll make setting up my triangle easier for me. Label any of the acute angles you want theta. Tangent is opposite over adjacent, and we can again use Pythagorean theorem. A squared plus b squared equals c squared to solve for the hypotenuse. 1 plus 25 gives us 26. That's not a perfect square, nor does it have a perfect square factor, so we will leave it as the square root of 26. We already have 2 of the 6 trig functions, so we need sine, which is opposite over hypotenuse. We can't leave that radical in the denominator, so we would multiply by root 26 over root 26, and I'll show you a fast way for rationalizing radicals as well. In the numerator, 1 times the square root of 26, and in the denominator, those radicals cancel. So notice what just happened. That square root of 26 from the denominator moved to the numerator, and the radical sign disappeared from the denominator. So we'll practice that with our cosine. We'll end up with that square root of 26 in the denominator again, as cosine is adjacent over hypotenuse. So the fast way to rationalize this, move that square root of 26 up to the numerator with the 5, and just drop that radical in the denominator. We know tangent, so we'll start with cosecant, which is the reciprocal of sine. I'm going to take the reciprocal of 1 over root 26, because when I flip that, it's rationalized, square root of 26 over 1. And finally secant, which is the reciprocal of cosine. Again, I will take that unrationalized form and flip it so that my secant is automatically rationalized as well. Some more SOHCAHTOA review. We're missing x, we know opposite, and we're looking for the hypotenuse. So we will use sine of 45 degrees equals opposite over hypotenuse. When your variable is in the denominator, you want to multiply both sides by that variable. And to finish getting x alone, we'll divide both sides by the sine of 45 degrees. Now when you use your calculator, make sure you're in degree mode, otherwise the trig function will be evaluated incorrectly. And I got about 28.284 for the x value, or the length of the hypotenuse. And we can't finish off our trig unit without a word problem, so we've got an airplane descending from an altitude of 30,000 feet, so that would be its vertical distance in the air. And the airport is 5 miles away. We're looking for the angle of depression. Now the tricky part about an angle of depression is that it's made with a horizontal line and a line of sight down. So this angle up here is really the angle that we're looking for. A couple of different ways to figure this out. We can use, remember, parallel lines. So we've got this horizontal line up here and a horizontal line down here that are parallel, and they're cut by a transversal. Are you having flashbacks to geometry? So alternate interior angles are congruent. We're also really looking for that angle as well. Another option would be to simply finish creating the triangle up there with the dotted sides and label that triangle instead. The other problem with this one is that we were given the altitude in feet and we were given the distance to the airport in miles. So we have to convert these to the same unit before we can set up SOHCAHTOA. Since 5,280 does not evenly go into 30,000, I'm going to convert my miles instead so I don't have decimals to use. 5 miles is 26,400 feet. Now we can solve for theta. We have the opposite and the adjacent. So tangent of theta would be 30,000 over 26,400. And when you're solving for an angle, you have to use the inverse function. So we'll take the tangent inverse of 30,000 over 26,400. Again, making sure you're in degree mode. And that angle of depression is about 48.7 degrees. For angles, rounding to the nearest tenth of a degree is as accurate as you need to be. The first you try, I want to check that you know how to use your calculator to evaluate trig functions. And our second you try is a word problem.